So we continue to provide information to the Ministry of Defense. And actually one of the components of this trip during this week are to continue those discussions with Polish industry about the industrial cooperation between Bell and Polish industries. The Viper and the Venom are 85% common. So visually, if you look at the main rotor mast and you move backwards, the aircraft are identical from that point backwards. As you go forward, obviously the cabin and the seats are different in the Venom, in the UH-1Y, and minor changes in the AH-1Z, but the cockpits are the same. So as you sit in the aircraft, you'll notice very minor changes between one aircraft and the next. What that allows for is there is a simplicity in logistics, simplicity in supply training, and so what that allows for in a regional capability in Eastern Europe would be there's an economy of scale that aircraft purchased through Bell would be able to afford. And there's also the economy of capability. So like you mentioned, you wouldn't have to have a training base in Poland and a training base in Czech Republic. The two countries, if they decided to, could share that capability in one location with simulated training devices as well as flight trainers. And then other capabilities such as a rework facility, supply warehouses, all of those functions that you need to support the aircraft wouldn't have to be replicated in both countries. They could be shared in one location. And it could be basically the training center could be in one location, supply center could be in the other country, and they could work back and forth. Basically what we created is a cockpit demonstrator for the AH-1Z aircraft. Now it is also common with the UH-1Y aircraft. So in one system we're able to show interested nations what the aircraft looks like in the cockpit. So in the AH-1Z the cockpits sit front and back. In the UH-1Y, the cockpits sit side by side. So what we can display is the glass cockpit, the functionality that sits behind them as far as the target sight system, the moving map display, the weapons functions and weapons integration. And so it's easy for us to show this is what the aircraft looks like when you actually see it. And it helps customers visualize what the aircraft looks like. They understand the UH-1Y and the AH-1Z 5 generations ago were invented in Vietnam. And customers believe that these are the same aircraft as what they saw in the 1970s. So this allows us to bring customers in. They can sit in the aircraft, they can feel the controls, they get the idea these are brand new aircraft, all combat capable, and they're expeditionary, and so they're deployed with the United States Marine Corps right now. So try to show them that these are actually new, and because they're common, it gives them a feeling of what the UH-1Y would look like versus the AH-1Z. The use of this demonstrator is a means of showing the customer what are possibilities for simulated training. So the most high-end simulated training would be a full motion, full flight simulator. Basically it's a large system in a dome that has full visuals. Then you can continue to step down in different levels of simulated training all the way down to something this size using a similar visual system that allows the pilots to train the weapons functions, button pushing, the symbology, and getting used to how the aircraft operates. The more you can learn of the glass cockpit functions in a simulator or in a simulated device, the less training you have to do in the aircraft. The Viper would classify as a heavy attack helicopter. However, it retains the agility of a lighter aircraft. So because she is only 1 meter wide at the cockpit and approximately 3.5 meters wide at the wingtips, it allows for a very fast, very agile aircraft. So even though she provides all of the heavy attack capabilities for anti-air, anti-ground, and with precision-guided munitions, she still retains that small aircraft feel when you're actually flying. The Viper aircraft was actually designed for the United States Marine Corps, and so in that, its target set basically span the entire gap from low-intensity conflict, asymmetrical threat, all the way to heavy tanks and the traditional force-on-force tank battles. Because the aircraft had to go wherever the U.S. Marine Corps went, it had to be expeditionary so it could be operated in the field, and its weapon systems could be used across that entire spectrum. So from the target sight system on the nose that allows the aircraft to see the enemy before it can engage with its weapons, and then it can decide when it needs to shoot. So it has the ability to look out and see the enemy before it can be engaged, and then all of the targets that it can pick from there, either with unguided or guided rockets, the smaller 2.75-inch rockets, through the Hellfire and the multiple variations of Hellfire warhead that it has, all the way up to an air-to-air threat. And it's the only attack helicopter that has an integrated air-to-air missile hanging on the wings, no different than any other weapon system. And then finally, the 20-millimeter cannon on the front makes it very reactive, either for an air threat, a ground threat, or basically something that pops up that they weren't expecting. One of the things that we've discovered is an aircraft that was designed to go aboard ships. Basically, it's called marinization and expeditionary capability. Basically, the aircraft is designed for shipboard environment. When it's designed for that, it actually performs better in all environments. So as opposed to if you design for specifically a European environment, it may not do as well in the desert or somewhere else up in the mountains. Where if you design for the ship, then it will perform better in Europe, it'll perform better in Afghanistan, in Iraq, in the Middle East. Because if you can withstand salt water, then it makes it better in all of the environments. So what this does, it allows for an ease of maintenance, because there's a reduced amount of maintenance that has to be done on the aircraft to keep it operating correctly because of that design. Things like the coatings on the airframe prevent corrosion. The aircraft is designed to be water washable. It's designed to shed water, so you won't basically hold on to water and create corrosion anywhere in the airframe. And the idea is that it makes it easier to maintain. So if it's easier to maintain, there's a less reliance on the maintainers and the support facilities. And one thing that we noticed in Europe is they tend to leave the aircraft outside, cover up the rotor blades, and they leave the aircraft outside. This is no different than how the U.S. Marine Corps operates its aircraft on the ships, is where they're sitting on the flight deck and they're fine for 8 months in salt water, and they're maintained that way. So it makes it a very rugged aircraft, and actually makes it easier for European countries to maintain them.